that the solution for assignment 1 is posted. Also, assignment 2 is up as per calendar that we shared, that I shared in the first lecture. The second assignment is due next Monday, so in a week. So again, please start working on it. And all the subsequent assignments, so 3, 4, 5, and 6, you're going to have 2 weeks. All right, so assignment 2 is up. A reminder also, it has 2 files. In PDF, as usual, the text of the assignment is there. And in the .py file, you will have to use it. This is where your starter code is for part 1 of assignment 2. Also, I seem to be getting some questions about when the deadlines are and the tests are. Recall that all of this was discussed in lecture 1. So lecture 1 was basically about course outline and logistics. So if you look at the slides of lecture 1, you will find a schedule of everything. And you will see that there was somewhere a schedule, but one of the things, this is the grading scheme, but here's the schedule. One of the things you're gonna see is the assignment 2, as I mentioned, is due on Monday, but also the first test, we're gonna have our first test on Saturday, this coming Saturday at noon. Basically, it's the length of the class, right? So our 20 minutes, well, here it says hour and 30 minutes. Okay, so a reminder about that. I'm not sure if I have any other logistics thing. So as you have hopefully seen, the solutions for assignment number 1 are up. I encourage everybody to look at them just for the purpose of learning, because of the fact that your the test is coming, for example, and to see, even if you solve it different and it's correctly, maybe you're gonna see a different way to solve this and so on. So what I'm gonna try to do for this class, first of all, we are going to cover if statements today, and a bit more of strings, so-called methods in the string. We're gonna see what that means. But so because for your assignment number 2, you're going to need if statements, and you're going to need a couple of these extra things you can do with the strings. So I'm going to show you all of that today. So basically at the end, you will be able to start working on it. There won't be anything else that you need once we finish with this. Once we finish with this class. Okay. So my goal for class 1 is to cover, as I said, if statement. That's going to be fairly simple. There's not that much to say, at least in terms of concepts and strings. Also, at the beginning of the class, I picked 2 problems from assignment number 1 to explain the, let's say, 2 among those from which I got lots of questions, students on the discussion board. So that I'm going to do at the beginning. Then we're going to continue with the new material. The material for the if statements is fairly simple. And again, note that kind of goal of the lecture is to explain the fundamentals. And in the beginning, the fundamentals are fairly simple, especially things like if statements. Goal of the labs is for you to apply those fundamentals, to solve problems. So for example, one of the things that you had in lab last week, lab number 2, is this question here that is very related to a problem in assignment number 1, where it seems to me that there was most difficulties that the students have, and I will cover that problem. So the goal of the labs is for you to practice these things, to solve problems, to get help from TAs for problem solving things, because the only way to learn how to solve problems is to solve a lot of them, okay? So that's the goal of the labs. And in general, when it comes to this problem solving, you are not coming from this, you are coming to Python U possibly, but not for the problem solvers. You all come here with 12 years of prerequisites of schooling that you have done. This is, so you're applying the knowledge and problem solving skill that you hopefully develop throughout your studies. Okay, and you practice and practice and you get better at these things. Okay, so Where was I? So before I start, I see one hand up. I'll take one or two questions and then I'm going to start with the lecture. I see Monica has a hand up. Go ahead, Monica. Monica, you did not unmute yourself. Oh, I didn't let you unmute yourself. Go ahead. Now you can unmute yourself. Go ahead, Monica.
Hi, can you hear me? Hi, can you hear me? Hello?
I still can't hear you. Go ahead.
Can you hear me?
Oh, yes, yes. Now I can. Go ahead.
Okay. You're sure you can hear me, right?
Yes.
Okay. Okay, so I just had a question and a follow-up question. So for the test this coming Saturday, have you said what it's going to be on, or is it basically just about the past 5 lectures?
So I didn't make a test. I plan to make it tomorrow. And
Okay.
so the material that will be covered is everything up to today, including today. So let's say everything up to tomorrow. So if statements and so on, next week we're already going to do loops on the strings over the elements of the strings. So you're not going to have that. So everything up to tomorrow. So basically that, because we're doing today, we are doing give statements for your assignments. You're going to be using give statements for your labs. So this week, so that material will be there, but not Wednesday when we're going to do loops. The questions, you can expect things like what you see in your assignment in your lab, write a function that blah, solve some problems with the tools that you have seen.
Okay.
Also in your lab, you have some tasks. So there may be something that look like those tasks that you have seen in your labs. I don't know yet. As soon as I finish making the test, I will share this information with you via announcement on Brightspace.
Okay, like information as in like what we should focus on for the test, like in terms of like strings or whatever it is.
Well, I'm not sure what to tell you about what you should focus. As I said, the material is going to be everything that we covered up until tomorrow. But more in terms of the format, that you're going to have some programming questions and maybe you're going to have some of those type of theoretical questions like you had in the tasks.
Right. Okay. Okay. And then also, you posted a reading list today. It says reading list from your main textbook, so chapter 1 to chapter 5. Is that stuff that we should read to prepare, or like?
That's a good point. Thank you for noticing. I did forget to mention this in the other section. This is the stuff that I find, at least for myself, that my knowledge always gets better if I read a different way or more detailed way for some things. So I recommend everybody who to also read the textbook. When you ask me, does this help with the test? I don't know. Whatever helps you to develop a way to be able to solve problems, things like you have seen in labs, and understand the material and the things that help you solve problems like you've seen in labs and assignments.
Yeah, but everything that it's in that reading list, so chapter 1 up till chapter 5, that's everything.
There's many sections skipped there. So in terms of really the material, it's the material that we covered in class, right?
Okay, thank you so much.
Okay, there's too many people now and I have to teach. I will take, I think there was one person that raised the hand first. That's going to be Otman. And then for the other ones, Kyla and Sasha and Aurel and Jason, please wait towards the end of the class. I'll be happy to take your questions. So Otman, what is your question? I can't hear you. Okay, so let's not do the question then, because we, at this point, because we didn't manage to get Otman, I'm going to actually teach. And as soon as I end, I'll take all of your questions for those of you who still have questions. So please put your hands down because I'm going to start teaching now. Okay, and then I'm going to take questions later. So maybe, hopefully I finish even a couple of minutes before the end of the class and you get to ask your questions, but I'm going to answer your questions anyways towards the end of the class. So let's look at the, assignment 1. I don't know if I have it open. Let me check. Yeah, there it was. So here's one of the questions that on the forum I get the most questions about, and even private emails from the students don't know even how to start with this. So let's see, let's recall what you had to do for this problem. So you had a 4-digit number. It says that given a 4-digit number, so given a 4-digit number, you have to check. So you have a number, let's say 1, 2, 3, 4. You have to check, are they two? The definition is that the number is not pale if it has 2 consecutive digits that are 3, or if the last digit is divisible by 4. So in this case, for example, this one would not be pale because the last digit is divisible by 4. So the definition was in terms of what's not pale, and you had to return true if the number is pale. So if you do not pale, you get who is pale. So let's do the testing for this case that the number is not pale. So let's see what were the tools that you introduced in the class, in the lab, to solve this problem. First of all, in the class, you will introduce the tools of integer division and remainder operation, something that you knew all the way from primary school. But before we get to the tools, how do you even know which tools to get to? So let's try to break this problem. So you have 4 digits in a number. So let's say your number has digits A, B, C, D. So what you need to test are first 2 digits, both equal to 3. Middle 2 digits, are they both equal to 3? Last 2 digits, are they both equal to 3? And I'm also interested if the last digit is divisible by 4. So this immediately, if you speak this, immediately tells you I should somehow be able to get first 2 digit, middle 2 digit, last 2 digit. Okay. Or if that sounds like something I've never seen before, what about I get these digits one by one? I get the first digit, the second digit, the third digit, the fourth digit, okay? And that you have actually seen in your lab, as I have already shown you. Let's look at here. In the solution to this problem, reversing the digits, you learn how to get individual digits of a number. So really, depending on your approach, there are actually different solutions to this problem. So one, if you were following, okay, I'm going to isolate individual digits. So let's say in A, I managed to get stored the first digit of the number, and B the second, and so on. You may now, okay, now that I got all 4 of these digits, I'm going to write a Boolean expression that tells me when a number is not pale, because that's how the thing is divided. So it's not pale, let's say, if the first and the second digit are 1, 1. So you write that 3, 3. I is equal 3, and if B is equal to 3, okay, then I'm definitely not pale, right? I found 3 and 3. I'm also not pale, so if this is there, I'm not pale. If B is equal 3 and C is equal 3, or C is equal 3, so third digit and the last digit, so last 2 digits, and D is equal 3. Okay, in all of these, so if first 2 are equal to 3, second 2 are equal to 3, third 2 are equal to 3, or I'm not pale if the last remainder of division with 4 of the last digit is 0. So the last digit is divisible by 0. This is when I'm not pale, but I'm supposed to return when I'm actually pale. So if you're not pale, if you're not pale, then you're pale. So you just do not of that and return that value. So that was one way to solve it, if you were individually isolating digits, okay? The way I solved in assignments, it's in a sense even simpler, because why isolate individual digits when the description of solution says you look at the first 2 digits, next 2 digits, and next 2 digits, right? So why can't I just get the first 2 digits and ask, is it equal to 33? Next 2 digits, ask if it, middle 2 digit, ask are they equal to 33, and last 2 digit, ask if it's equal to 33. So here's how I did it. So, okay, so let's say in variable, let's say in variable first 2, how do I get first 2 digits of, how do I get the first 2 digits of a 4-digit number? Okay, You know that if you have 4-digit number and if you divide it by 100, you're going to get a 2 digits, point, and some decimal spaces. So I don't want those decimal spaces, right? So if I divide a 4-digit number with 100, I'm going to get first 2 digit, then something. So in fact, because I don't want the rest of the decimal places after the dot, I just do integer division with 100. It's going to give me first 2 digits. So n integer division with 100 is going to give me first 2 digits. How do I get middle 2 digits? Okay. Well, if I want to get the middle 2 digit, I don't want a first digit and I don't want the last digit. So how do I get rid of the first digit first? If I don't want a first digit and I want last 3 digit, well, I can ask for a remainder of division with 1,000, because that first digit is actually thousands and it's going to be gone. And I'm going to just get as a remainder of the 3 digits, last 3 digits of the number. So I can say that the middle, first I do mod, like a remainder of a division with 1,000. That's going to give me the last 3 digits. Okay. But so now that I have these last 3 digits, I want to remove the last digit, okay? Because I just want the middle 2. So if I have now a 3-digit number, I want to remove the last one. Well, I just divide by 10 because that's going to remove the last digit, right? So, and I use integer division because I don't want those decimal places. So that's how you get the middle 2 digits. And finally, last 2 digits, I get, well, I want the last 2 digits, but then I should just do remainder of division with 100 because we have thousands and then hundreds. So that's going to get rid of the first 2 digits and it's going to give me as a remainder the last 2 digits. So n remainder of division with 100 is going to give me last 2 digits. Okay, and the assignment is also asking you to test the last digit, LD for last digit. Is it divisible by 4 to get the last digit? Remember, if I divide by 10, I'm going to get 3 digits, point something. So I don't want that point something, so I instead do integer division with 10. So I do n integer division 10. Sorry, remainder. So I'm going to get, so there's two ways to do this. But the simplest one is to ask for the last digits, is to ask for a remainder of division with 10, because we are going to get rid of the thousands and hundreds and tens. So we're going to only get the ones. So we're going to get the last digit. So now we have all the digits. So that was the first part. I get all my digits. First 2, middle 2, last 2, and a last digit. And now you just test what we asked. We are testing when a number is not pale, because that's what the definition did. So first 2, I'm asking, are they equal to 33? So I'm testing, is one of those bad events not there? Or is it true that the middle 2 are 33, or last two are equal to 33. Okay, so do we have one of these events? And what's another one that we're testing? Is last digits divisible by 4? Okay, so it's remainder division with 4 equal to 0. So if at least one of these things is true, the number is not pale. And notice that we are saying at least one of them. So we glue this condition with or. We are testing if at least one of them is true, the number is not pale. Otherwise, the number is pale. So we can just do not. If none of this is true, so we not it, we get that the number is pale. So that's basically the solution that I presented, as I showed you already. There's many ways to do it. One I showed you first, when you isolate second digits. Even in terms of writing Boolean expression, if you find it confusing to define that a number is pale if it's not pale, you can write this expression without using not, if you like. You ask yourself, when is number pale? It's pale if the first 2 digits are not, so now we are changing, are not 33. And what do you need? And the middle 2 digits are not 33. And I need that the last 2 digits are not 3, 3, and I need that the last digit is not divisible by 0. So I need all of these to be true for a number to be pale. So I'm using AND. I need that the first two digits are not 3, 3, that the second two are not 3, 3, that the last two are not 3, 3, and the last number is not divisible by 4. Okay, so that's yet another way to solve this problem. Okay, so that's about the number 4 in the assignment, which is about pale numbers. Jason and Otman, I'll take questions only at the end. So can you please put down your hand? Thank you. You can remember your questions. You can ask anything that was related in the class, or as you know. Okay, just write down your questions and remember what you want to ask. All right, so that was about question 4. Another one that I picked that I got quite a few questions on the discussion board is about question 9. So let's see what it is. And I wanted to show this one because it actually has to do a lot with, appears a lot in computer science, as you will see if you continue studying. But let's first see what we need to solve for this problem. It says that this function takes an input, a number bigger than 1. And then you imagine dividing that number by 2. You divide by 2 and ask yourself, am I now less than or equal to 1? If the answer is no, you divide by 2 again. So you keep on dividing yourself by 2 until you get a number less than or equal to 1. So basically what you need to do is count how many times you have to divide a number by 2 before you get something less than or equal to 1. So let's try to write that down on a paper. All right. So what do we want? I have a number n, and I divide by 2. Let's say n is 8. I divide by 2, I actually get 4. Okay, and it tells me divide again by 2. So keep on dividing until you get a number less than or equal to 1. So I divide once, I divide a certain number of times until I get a number less than or equal to 1. Okay, so in case of 8, I would need to do it divided by 2, 1, 2, with 4 times, with 4 2s, okay, before I get something, actually 3, with 3 2s before I get something less. So in case of n, the answer would look like this, okay? So in fact, we would get equal, right? So what you wanna know is how many of these 2s are enough such that this equation is true, such that I get less than or equal to 1. So when we don't know what n is, I'm asking myself, how many times can I divide n by 2 before I get something less than or equal to 1? So what do we have in the denominator? I'm having 2 times 2 times 2, x times. So incorrect, the question is asking, so what I want to know is, what is this x? How many times 2 appears on denominator, okay, in this equation? So what I have here, instead of writing 2 times 2 times 2, I write 2 to the x. That's the same, right? I'm asking, what is x? What is x such that this is true? All right, so this is an equation that you all should be able, based on the prerequisites, you should be able to solve. If you don't, please pay attention, because the result of the solution of this, so let's get to it. And I'm going to tell you where it's going to show up throughout your schooling, if you're in computer science, software engineering, even computer engineering. I think computer engineering, you still have to take efficient algorithms. All right, so what do we get here? So let's write this another way. We get that n is less than or equal to 2 to the x, okay? So you have to solve this equation. You want to know what is x. So you're asking 2 to the what is n? Well, the answer to that is log base, whatever this base of exponent is, so log base 2 of n, okay? So as long as your x is at least log base 2 of n, Okay, that is the answer to this question. And this function is in Python. And what I wanted to say is that there's nothing much more complicated about logs than it is about exponents. Hopefully you all know exponentiation, 2 times 2 times 2, x times, it's 2 to the x. Log is just an inverse of that, right? So if I'm asking what is n in this equation, you're going to say n is 2 to the x. It's exponent, 2 times 2 times 2, n is 2 to the x. If x is given and you're asking for the n, you have an exponential function. But if n is given and you're asking for x, you're asking 2 to the what is n, then that function, x, is log base 2 of n. Okay, and it's a very slow growing function. It appears a lot in computer science. It's the base of the many. It's going to appear once you learn efficient algorithms, and this is what distinguishes computer scientists, good computer scientists, those who are going to get best jobs, who's going to be super valuable, are those computer scientists who know how to design efficient algorithms. Right now, for that, I can't explain what it is because I would have to explain what efficient is, how you count operation, and we're going to get to that a little bit, at least towards the end of the semester. But it is actually the whole study of computer science. You're going to get to that first for real, as a part of the whole course is dedicated to that in your data structure and algorithm course that you're going to take in the fall of your second year. Okay, but let me just mention that efficiency of algorithm has nothing to do with the lines of code. Okay, it's the loops that I expanded. It's about the number of operations that your solutions do. And again, this is the whole science about computer science, is about designing solutions that do as few operations as possible. Okay, but as I said, we're going to see some beginners things about efficiency of algorithms towards the end of the semester. Right now is not the time for that. But in many of the best algorithms, the number of operations, log base 2 of n, appears in the number of operations. So as a computer scientist, please do make sure that you know these functions. Okay, so basically for that assignment, for that question 9, the answer was just log base 2 of n, and then you just had to figure out, do I need a floor or a ceiling? So should I round up or down? And for that, we needed a seal for this particular question, but that is more kind of a details that I don't want to spend time on now. Okay, so that's all I wanted to show you about assignment number 1. What I'm going to do next is basically the topic of today's lectures, which is if statements. So let's try to understand what if statements do and what is the syntax in Python. So for that, I have a few slides. So here's basically, here's a type of a program that you have seen so far. So in this particular example here, Python, no matter what you do, the Python is going to execute every line one by one. Okay, there was no situation where you would have something like, in this situation, do these lines of code, in this other situation, do different lines of code. And as you can imagine, and somehow an image, you can imagine graphical depiction of such a code is like a straight line. You do commands one by one sequentially. Okay, there is no change. There is no fork in the road. Then in one situation, I'm going to go follow this path, and in the other situation, I'm going to follow this path. Okay. But in life, as you can imagine, for so many things, you have actually a fork in the road. And things you're testing some condition, and depending of the result of your test, you're going to do one thing or another. Here's a trivial example. You may say, if it rains, I'm going to take an umbrella. Otherwise, I'm not going to take an umbrella. Something super simple and trivial. Okay, so so we're going to see basically 3 types, but they're really all one same type of if statements. So let's at least start with the simplest syntax. So here's the syntax of the simplest form of if statements, is this block here. So you start with the keyword if, all right? And then you have a condition. What this condition is, it's some statement that gives as a result true or false. And then you have a colon, All right. So now this condition, could I have a glass of water, please? Thank you. So now this condition, if it's true, you look at this if statement, you look what comes after the colon. You're going to see indented block of code. So if that condition is true, you're going to execute that indented block of code. If the condition is false, you're going to skip that block of code and continue with the program. How do you know where is a continuation of the program? Or you just look what's lined up with the leftmost edge. And in fact, here what is lined up with an I of an if statement, that's where you continue your program. So this type of if statement is called one-way if. So it's the simplest kind. You have a test. If the test is true, you're going to execute the block of that if statements. You know which statement belong to the block because they're all indented in. That's how you're telling Python, here's a piece of code, here's a line of code that I want you to execute only if the condition is true. So once you execute that, then you continue with the program over here. If the condition is false, you're going to skip that block and continue where the program continues. So here's a typical graphical depiction of if statement. The conditions that you're testing. So let's look at actually here, here I have an example in actual code. You have an if statement, then you have a condition which is testing temperature. You're asking, is temperature at least 29 degrees? If it is, you want these two Python function calls to be executed, lines of code to be executed, and then you continue with the program. Otherwise, if the temperature is less than 29 or equal to 29, you're going to skip this indented block, so these two lines of code, and you're going to continue program outside of if statement. So this part here, this print statement, is actually outside of the if statement, right? This is just where the program happens to continue. So let's look at this graphical depiction. Think of it as you have a fork in the road, and you perform a test to decide which path you're going to take. If the temperature, let's say temperature is 30 degrees, you're going to follow this path and continue. If the temperature is less than or equal to 29 degrees, you are going to go this way, okay? So in the case when the temperature is 30, we are going to print it's hot, be sure to drink, I can't even see what because I'm drinking some liquids, and then you continue a program over here. And if it's 10, this is false, you're going to follow the false fork that skips this block of code and continues. We're going to have a print goodbye. Monica, please hold on to your questions for a little bit later. Let me finish this. Okay, so this is a one-way if statement. Why is it called one way? Because only in case that condition is true, you are going to do some extra work if you want. Otherwise, you just continue with the program. So that's one example. By the way, notice that this indentation is very important. So here, ask yourself, if these two blocks of code are the same. So what does it actually mean for two programs or two blocks of code to be the same? Even if they don't look the same, they can be the same. For example, I gave you 3 different solutions to question number 4. They're all correct, and no matter for the pale number, meaning that no matter what input n you give it, those 3 solutions will give the same answer. That would make those programs equivalent. When are the 2 programs not equivalent? If there is some input, if there is some run that doesn't give the same answer. So you ask yourself, for the program on the left and for the program on the right, is there some value for the temperature for which they don't give the same answer? I'm going to take a sip of water while you think about that. Okay, for example, if you pick temperature bigger than 21.9, let's say 35, this is true, all three of these things will be executed. And the same on the right-hand side. If the temperature is 35, this is true, you're going to execute the block of if statement, then you're going to continue and print goodbye again. The difference comes, however, they're not the same, because if you pick a temperature that is less than 29, let's say 10 greater than 29, that's false, and this block, if block, will not going to be executed. So the program on the left is going to do nothing, right? It's not going to print anything. The program on the right, you get a false, and it's going to skip the if block, the same way it skipped the if block here. And then it's going to continue with the program the same way it did here. But here, the continuation of the program contains this print statement. So print goodbye is a continuation of the program. It's lined up, P here is lined up in an if. So this is outside of the if statement. So the program, when the temperature is 10 degrees, is going to print goodbye on the right-hand side. And this one here, not, because all three statements are inside of the if block. So indentation is critical to tell Python what you want to be part of your block that needs to be executed if the condition is true, and what is actually outside of it. What is the continuation of the program? All right, so that was just on the side to indicate the importance of indentation. So here's a second, let's say, second syntax-wise, a form of an if statement. This one you use when you want some action to happen, some separate action to happen in the case, in the false case as well. So you're testing some condition. And in this case, let's say we are still testing if the temperature is greater than 29 degrees. If it's true, as before, you execute the if block. Oh, it doesn't let me. You execute these two commands in the if block. If it's false, then you're going to execute the else block. I mean, explaining this sometimes it feels like it's worth explaining it than actually just reading it. So one way to see this is really to read it as if otherwise. So if this condition is true, you execute the if block. Otherwise, you execute what is indented in the else block. So here's the syntax. You have if and the condition. If it's true, you're going to execute the block of the if part. Otherwise, you're going to execute the indented block of the else part. And then, as always, so this is one if-else statement. So this is one if statement. And this here, we are outside of if-else statement. You know that you're outside again because you lined up with an I. You lined up with, in this case, with the leftmost edge of the code. Okay, so here's a graphical depiction of the code here. You have a fork in a load, you test in the temperature. If it's true, you're going to execute these two lines of code, print it's hot, and be sure it's to take liquids. If it's false, you're going to execute different two lines of code, print it's not hot, bring a jacket. And then you are outside when these forks meet, you are actually outside of an if statement and you continue with the program. It just so happens that program on the outside prints goodbye. Okay, so that is, that's the if else syntax. Okay, so now let's write a little bit of code with it. There's a third form that I'm going to introduce as we are writing code. Okay, so I'm trying to remove this from the bottom of my screen, but I seem to have, anyways, I'm gonna try to ignore it. You don't even probably know what I'm talking about because I really need to do something about this. Okay. All right, so we're gonna go to idle and write some first, let me actually, all right, so let me start in the shell. And remember what we did for, on one of the, maybe even on the first day, well, lecture 2, we'll learn that probably one of the simplest function that you're going to find in Python buildings is this ABS function that stands for absolute value. So this function, if you give it any number, it's going to give you a positive version of that number. Okay, and that function is in the Python built-in. So let's design our own version of ABS function just as a simplest possible demonstration of if statements I can think of. So we want to define a function called absolute value. So we want to code our own. So we are given a number x. Let's put doc strings just so we understand what the input is. So x is a number, and I'm going to return a number that is a negative version of the given number x. Sorry, positive. Positive version of the given number x. Okay, so what do we need to test? This is trivial here. I need to test if x is less than or equal to 0. In that case, the function should return minus x, right? We want to turn it into a positive number. Otherwise, so what's otherwise here? So if the number is not less than s, sometimes it helps to put commands for yourself to remember what case we are in. In this case, it's really trivial. Sometimes you may have more complicated else statements, so it helps to remember what case you're in else. So you just put otherwise x is non-negative. It's a note to self, but you don't have to have that there. And when you do return x, okay, that's when x is actually 0 positive. Okay, so that's it. Basically, we are done. So one version is done. We are using if statement to design our own ABS function. Let's call it. It seems to be working. But here's a question that you should ask yourself. I seem to have given exactly the same name to my function as I seem to be given the name to my function as I did as Python's function. So when I'm actually running this ABX function here, how do I know, or how do you know, which one am I running? Am I running Python's ABS absolute value function, or am I running my own? How would you figure that out? I think I actually have allowed you to unmute yourself so you can speak. How would you figure out if this is your own ABS function that we're running or this is Python ABS? Somebody speak up.
I would use help, like in the Python shell.
Okay, so let's see what ABS function we are running. Well, it seems to be the one that has this type contract, so it looks like it's ours. If I remember right, this was not the part of help function of Python ABS. An even simpler one, and the only reason I'm showing this is I strongly encourage you to try anything that comes to your mind. You just type it in, including when you were solving this pale number, you just try. You see what happens when I do integer division with 1,000, with 100, with 10, remainder. Learn that way by playing with things. But here's before, in other languages, you don't have these help functions. Here's how I would figure out which one it runs. You know, I would just print some nonsense that surely, if it's running Python's ABS, then it's not going to print blah. If it's running mine, it's going to print blah. So let's see, ABS minus 10. It returns positive and prints blah. So it's running my own ABS function. Okay, you see, there's somebody. Everybody mute yourself, please. So here's a problem of trying to leave you unmuted. Okay.
人们对处女膜最大的误解就是，很多人听名字就认为它是一张完整的膜，所以以为第一次会是这样。
Excuse me.
到的话，这个就是阴道膜。很多人会认为这个就是处女膜，并且认为。
Okay. So here's now you understand why I'm doing this, but I'm going to continue with the lecture. Hopefully the person will realize this, because for example, I can't solve this now on my side. That's why I mute you. Otherwise, I really wouldn't mute you. I would try to have exactly the same experience that we would have in the classroom. Okay, so here, so let's go back to, so one thing to remember here is that
可以理解为它是胚胎发育的遗留哺乳动物都有，比如黑猩猩。
I trying to figure out, is there a way for me to figure out who is speaking? All right, mute, mute. Anyways, this is Mission Impossible. Oh, mute all. I have a mute all button. Mute all. Okay, hopefully now. Hopefully now it's going to work. That's why I'm doing this. Okay, sorry. One thing to notice from this, first of all, do your own playing, figuring out of the language. Second of all, notice that the Python's function names are not reserved words. So again, as mentioned before, Python's counting you that you know what you're doing, and if you really want to rename their own function, you go ahead, do it, and it's going to use your function, right? The reserved names are things like keywords, like if, else, the orange one that I colored orange in idle, the keywords you cannot use as a name for your function in variables. Okay, so let's go back to the simple code. One of the things that you may ask is, and this is more of a game really than the question of readability and the style. It can be true that some code with less lines of code is more readable, but you can also go to another extreme that if you're trying to make your whole program fit in one line, it becomes unreadable. But let's try to actually play this game and try to say, okay, I'm looking at this solution. Is there a solution with less lines of the code? Okay, all right. So, but then you should ask yourself, when is there nothing to do really? If the number is negative, I kind of need to turn it into a positive number, but otherwise there is nothing to do. So if the number is already positive, I just return it. Okay, so if the number is negative, I make it negative and return it. Otherwise, this line of the code, if the number is positive, this line of the code is not going to get executed, and we come here and just return this positive number. This is like a continuation of your program. You are outside of the if statement. Okay, so this line is only going to get executed when the number is negative. So when the number is positive, it goes straight here and return a positive number. So this is another correct solution. For those who are new to programming, it may be confusing. It may look like, wait a minute, when the number is negative, you're going to both return here and then you're going to return here. Okay. However, please remember this rule about the functions. And I think I mentioned it the last time. There are two ways for functions to end, to terminate. Every function, the moment it encounters return statement, it returns the given value and terminates, no matter what comes after return statement. Nothing that comes after return statement will be executed. So the first encounter of the return statement, the function terminates. So if the number is negative, you are going to, this is going to be true. You're going to execute this block, the block of an if statement. So it's going to return the positive version of that number and terminate. So it's never going to get to this line. So you're not going to return twice, one after another. This doesn't exist. The function only returns once. Okay, I'm going to get to that briefly in a moment. But for that reason, because this is kind of, for some may argue again, this, you can argue one way or another, but certainly there is a school of thought that you shouldn't have two return statements in a function because it may make it less readable. And in that case, how do we get rid of one of these return statements? How do we write this code such that it only has one return statement? So let's see what we want to return one value, right? We're going to return one number no matter what. If the number is positive, there's nothing to do. If the number is negative, well, we should just change that number. So why don't we just do this then? Okay, so I'm going to make X, I'm going to store in X the new value, the one that is negated. It's going to be positive. So I change X into a positive number in case X is negative. Otherwise, there's nothing to do. And once I'm outside of if statement, I return what is stored in X, which in both cases will be a positive number. So here's a third solution to that problem. Arguably, actually, the one that is most readable and shows most what the function does, and it has this nice property that you only have one return statement. Okay, so that's it for if and if else if statement. So let's look at a situation where you need to test more than one thing, which happens very often, okay? So say we want to write a program. So when you're filling these forms, often in life you have to fill some forms. And very often you're going to bump into these questions that are asking you for your age range, like which box you belong. Are you less than 20? Are you between 20 and 45? This is, for example, a group that is most interesting to advertising, or at least it used to be, because they consider people who spend the most money, but that is a different topic. So, you know, you fill some forms and you figure out your age, which box it belongs to, so which category it belongs to. So let's write a program, or rather if statements, that prints a different message. In fact, I think the version I showed in last class actually was writing a function. So let's write a function, since I was writing a function in a previous one. So let's write a function that given input an integer indicating person's age, sorry. So let's write type contract just so we know age is an integer. It's your, it's an age of somebody using this function. And what I want to do is return a descriptive age of the person, meaning what box they belong to. Don't get hung up on the box. I mean, just string explaining their age group. Okay, so I'm going to return a textual string describing their age group. Okay, so let's say that for those people who are less than 20, they live so few years, and every one of these years is so important and memorable that we really want to return their exact age. So for those who are less than 20, I want to return their exact age in the form of a string, because I promised here that I'm going to return a string. For those who are 20 and above, but less than 30, I'm going to return 20 something. For those who are 30 and more, but less than 40, I'm going to return 30 something, and then something else for 40 and above. Okay, so we have one variable, in this case age, and we want to test several conditions, not just one. In the previous syntax form of if statement, we were testing only one condition. Is temperature greater than 29 or not? But if you want to test more than one thing, for example, is temperature greater than 29, do this. If it's between 0 and 29, do something else, and otherwise do a third thing. So if you want to test more than one condition, you're going to use an additional construct called elif. You're going to use elif keyword to add extra conditions. Okay, so let's see how to do this for this problem. We said that if age is strictly less than 20, that we are actually going to return an age. So actual age of a person. So I'm going to return age, but because I promised to return a string, I'm going to return age in the form of a string. Okay, that's one thing. All right, then the next thing I want to test is person age between 20 and 30. Okay, so basically 20 and above and less than 30. So I want to test if when is a person 20 something? If your age is at least 20 and your age is strictly less than 30, then you're 20 something. Okay, so I'm testing here that you at least 20 and at most strictly less than 30. And in that case, I want to return, oh, this person is 20 something. Okay. And let's say actually, because let's stick to this notion, let's not have more than one return statement. So I'm actually going to just remember result. Well, let me do that again. Return, in that case, I return 20 something. Okay. Actually, I made a mistake here because I'm testing next condition. So if you want to test more than one condition in one if statement, I'm going to explain what I mean by one if statement. You're going to use elif, right? So if, and then you can have as many elif condition testing as you like. Okay, so if this is not true, check if this is true, if is the age between 20 and 30. Okay, and then I have another one to test. So I'm going to use elif. Is the age is at least 30 and age is strictly less than 40, then the person is 30 something. So I don't want to do this for 40s and 50s and 60s. So I'm going to say everybody over the 40, who cares, right? So certainly not you guys who are 18 and 19. So let's return here, I don't know. Otherwise, if you're none of these, then for all purposes, you're ancient. Okay, so we wrote a function. Let's see what it does. All right, so let's see if the person is 12. We indeed return their age. If the person is 27, they're in their 20s. If they're 33, then they're 30s. If they are, I don't know, 44, apparently they're ancient. Okay, so it seemed to be doing what we asked. But here's the main thing I want you to remember. This is one if statement. What does that mean? Only one of these blocks is going to get executed. So if statement, so now that you've seen the full form, if, then as many elifs as you want, and then else, that is one if statement. The only mandatory part is if. Elifs don't have to be there and else does not have to be there. So this does not have to be there, then you back to one-way if. If elifs are not there, then you back to two-way ifs. If everything is there, you are here for the full version. What makes the beginning of the if statement, the main thing you have to have there is if, okay? So here's one if statement, and only one true block will be executed. What do I mean by that? All right, let me change this. So this code actually, we talked before, when are two codes the same? Right now I made a change. These two, this code and the previous one, in fact, let me put it back there. All right, just so you can compare. The code is old. This and this is identical. When you were looking at this, hopefully you noticed that it can never be that age, we have three conditions, right? Actually four. You're testing if is the age less than 20, is it between 20 and 29 basically, is it between 30 and 39, and is it more than 40? So these conditions so far were disjoint, okay? There couldn't be an age that meets more than one of these things that we are tested. So then hopefully it was clear to you that only one of these blocks will be executed. But actually this code here is identical. We talked about what does it mean for the code to be identical. It does identical work. No matter what input you give it, no matter what age you give it, it's always going to do the same job. Even though, let's look at age 25. Sorry, let's look at age 15. Age 15 meets all of these conditions. 15 is less than 20, 15 is less than 30, 15 is less than 40. And you're not going to execute all three of these blocks. In one if statement, you're going to execute only the first true block. So in the case of 15, you get true here, okay? 15 less than 20, it's true, so you're only going to execute this block of if, this block of the if statement. Let's say you pick 25. You're going to get false here, so obviously you're not going to execute that block. Here you're going to get 25 less than 30, you're gonna get true, and 25 less than 40, you're also gonna get true, but only the first true block will get executed. You execute this and leave. You may say, oh, wait a minute, but you just told us as soon as you execute return, it's gonna stop anyway. So clearly it's not gonna do both. But let's go and do a result, actually write the version of this code that only has one return statement, which, as I said, many would argue it's a much better style. We just remember what we want to return. So in this case, again, this is completely identical code. And in case when age is equal to 25, you get true statement here, but only the first true block will be executed. So we get a true here. It's going to set result to 20 something. Then you leave this if statement. This is one if statement and the continue program. Where do you continue? Here's the next line of this function is going to return 20 something. Okay, so here's something to remember. I'm emphasizing this so much, although for those who programmed before, this must be super simple. The reason why I'm emphasizing this is in the past when I was giving tests and would have questions of this form, between quarter and third of the students would get this wrong. Let me give you an example of where. Let's say we are just printing this. The question would be of the following form. For example, I ask you, print 20 something, print 30 something, and here print ancient. And let's say it's really, we changed the problem, we are printing the message rather than returning any strings. So actually this would change the type contract here to none. No, that's for this particular case, that was the point of the lecture. Okay, so we're looking now at a different version of the format age function that takes as an input age and prints a message about age. So I would ask, okay, I will show code like this and ask format age. If I make format age 25, what does it print? Okay, there would be a quarter or a third of the answer where the students would, for that, write both, that the function prints both 20 something and 30 something. The question wouldn't be this obvious, because probably if I'm giving you this name I'm giving you the variable name is age, and then I'm putting 20 something, 30 something, there could be many who would just guess that it only prints 20 something. It wouldn't be something that you guess, right, based on the content. Okay, so if the age is 25, only this will get printed because 25 is less than 30. Don't confuse, so let's see this. So this is one if statement. Okay, so let me ask you two questions. So there would be a question like this. Of course, there wouldn't be age and this. It would be something nonsensical printed, so you can't just guess on the content. So if we do format age, we have one if statement in there, and only the first true block gets printed. So even though both are correct, only the first true block executed. So we print 20 something, and then we outside of if statement and we print goodbye. Okay. Let's look at this. This is completely different design. You're asking now, what does this print? Okay, but this has three if statements. Here's one if statement, here's another if statement, here's another if statement. Okay, so this type of, I'm gonna get to your questions. We are getting close to the end. All right, so format age, 25, right? 20 something, 30 something goodbye, because this is one if statement, it gets executed, we get a false here, so the age is not printed. We continue the program, oh, it just so happens it's another if statement. You have to be able to figure out where an if statement begins, where it ends. So the if statement always starts with if. When you encounter the next if, that's your new if statement, okay? So here's a new if statement, you test. So this is basically one way if. You test is 25 less than 30, the answer is true, so you execute this block. So we continue the program. Where is the continuing program? Oh, here it is. What do I have there? I have this if statement. It's asking me to test if age is less than 40. Well, the answer is 25 is less than 40. That's true. So it's going to execute 30 something and skip else block, because this is one if statement. So we print 30 something and skip ancient. I have a mistake here. This should be a string. And finally, we move to the next line of code, which is this, print goodbye. And that's why it prints this here. Okay. So that's all I want to show you for if statements. So if keyword is a must, the other blocks are optional. In fact, so much so that you don't even have to have elif, don't have to have else. So elif is optional, else is optional. Even this is a valid if statement. You can have, sorry, let me remove the else part. It could be that you don't want anything in the else. This is also fine, okay? In this case, sorry, elif. All right, so let's look at this one here. This is one if statement. It has an if block. So if block is always there, and it has two elifs in each, but this is still one if statement, and only the first true block is executed. In this case, if I pick 50, none of them will be executed. False, false, false. I continue with the program. Okay, so that's all for the if statement. I'm going to spend my couple of minutes telling you a little bit extra about the strings, the part that you're going to need for your assignment. We're going to be done basically in 5 minutes, and then I'm going to take your questions. So here, you already seen quite a bit about the strings, but here's some useful things about strings that you haven't seen yet. For example, there is a super powerful operator. It doesn't work only for strings, but we are seeing it for the first time. It's called in, okay? It's a Python operator, if you like. Deep down, it's a function. You're actually calling a function, but let's not get into it. So here's how you use it in strings. Okay, so here, I'm in Python shell, which you know, because you see these 3 lines. All right, so let's say I construct, I'm asking, is letter M in, maybe I have better font than actual idle. So let me remove this and go to idle because it has nice bigger fonts. I was in terminal there. So no difference except that the fonts and the colors are missing. So let's say I want to know is lowercase m in word or string mother, okay? And it gives me, so when you're asking in, it's going to give you true or false, right? So you're asking, what you're actually asking is a string m part, a substring of string mother. So in this case, true. It's case sensitive. So if you do capital N, you're going to get false. Okay. It doesn't have to only be one letter. You can ask any string. For example, you can ask if th, string th is a substring of mother, you're going to get true. But if you ask is mr substring of mother, you're going to get false because mr is not a substring of mother. Letter m and letter r in mother, but they don't appear consecutive. They don't appear as a substring of mother. So n, you can use in operator to ask some things about your string. Okay, so strings are text, right? And you will use, text is unavoidable in everyday language, in everyday life, should I say. Obviously in language is unavoidable. In everyday life, text is unavoidable. Therefore, it's basically unavoidable in your coding. You need it all the time. So Python and all the other programming languages provide you with extra things you can do with strings. Those things are not in built-ins. They are in Python module called str. As before, you can ask Python what type of functions you have there for me, so I can already use them. And you can see them here. One thing that is different between string library, so string module, and modules that you used so far, which is like Turtle and Math and random module that you're going to need to use in your assignment. One thing that is different that you don't have to import it. Basically, it's imported by default. So you don't have to import it because simply it's easy to imagine that maybe you're going to be writing a program where you're not going to need some fancy math functions, or Turtle's definitely easy to imagine that you're not going to be using any Turtle, so you don't import it. But it's hard. Most of the programs you're going to be using some text, so the string module is imported by default. You have a number of very useful functions there. Remember to look at what functions you have. You ignore for now everything that starts with underscore, and you get this nice list of functions that do things with strings. So for example, already this first one that we're looking at is capitalized. You can guess that if you give it a string, that it produces a new one with all the letters capital, or maybe just with the first letter capital. You play with it to figure out, or read help pages to figure out what it is. There is a lower one over here that's going to turn all the letters into lowercase letter. But here's the one that is going to be useful for your assignment. In fact, you have it in the hint of one of the questions, which is count. So let's do read help pages, because not just for it seems easy to guess what count is or not. That's not the point, but I want to draw your attention to something here. So let's ask Python what count does from str module. Okay, and let's go back to asking about ABS, absolute value. All right, so we have here, please notice this. First line, this says method, this says function. Please, when you're reading help pages, always pay attention to that. You must, otherwise you won't be able to properly call the function. What is the difference? They're both functions. So far we were using this almost inclusively, not quite. These are the functions. If you see that it says function, that means the way to use it, the way to call it is first you put function name, then you open parentheses, and then you send any values or basically arguments separated by comma. So you start with the function name. Okay, but method, when you see a method, you don't start with the function name. You start first with a variable, then you put a dot, then you put a function name. And then you wonder which variable? Well, it's going to be variable to which you want to apply that function. So for example, if you have a string and you want to apply a lowercase function to it, and let's say string is stored in variable s, you would do s dot lower. So this is so-called object-oriented way of calling functions. You have seen it in your assignment. Were you calling any function? Well, I muted you all. So let me remind you when you did it. Almost basically everywhere, we were only making functions calls, like a name, then parentheses. But when you were building your turtles, if you create a turtle and you name it T, if you wanted to apply a function forward to turtle T, you didn't call it forward and then tell it move turtle T. The way you called it is you put a variable T, then dot, and then this meant apply function forward to turtle T. That's an object-oriented way of calling function. In fact, if you did dir on turtle.forward, hopefully the documentation is correct, you would get, not dir, sorry, help of turtle.forward. You would see, you see, actually, unfortunately, it's not correct. This should say method. I wanted to show you that, but it's actually not correct. Well, that's too bad. Okay, so pay attention, at least in the Python, I mean, Turtle is things that you import inside, at least in Python core things. When you see a method, you should make a call in an object-oriented way. So a variable dot, then the function name. When you see a function, you call with the function name and then the rest. All right, so what does the function count do? If you have a variable, let's say we have a variable Mostar, string Mostar, for example, and I'm asking, in this string, count how many times some substrings appear. So let's say how many times substring MO appear. It's going to tell you it appears once. You can ask how many times substring OO appear. It's going to tell you it appears 0 times. Let's create another string, alarm, la, blah. Okay, and you can ask, in a string S2, how many times a substring la appears, and you're gonna get that it appears 3 times. We have it here, we have it here, and here. So in other words, function, a method or function count from the string module counts how many times the string that you're given as an argument appears in a string whose variable you put before the function call. Okay, so give how many times this appears in here. So this will be useful for one of your assignments. In general, there is many useful things. One of the things that you really are going to need to use, last thing I'm going to show, is that here's what happens all the time. You're asking somebody things like, what is your name? You're gonna need to do that. You already did in assignment number 1, but in assignment number 2, you'll have to do a little bit of beautifying of that. You ask, what is your name? And you're gonna store it somewhere. Okay, but maybe I don't like how close this is, and I'm gonna do it like that. Let's look at what's stored in name. I really want just the name. Let's ask how many characters this variable name has. It has 19 characters because I put so much space. Really, I just want to have a name of this person. Python has nice tools in the string module to get rid of this. You can strip the white space before the name, before a string and after the string. The function for that, and you can guess, is actually strip. That function removes the white space before and after a string. So if we call it, we have this string name. I want to strip it of the white space. What it's going to do is going to create a new string where the white space before and after is removed. So hopefully you can see that it's useful. By the way, please notice again that this returns a new string. So name is still with all that white space. So if you want to change that, you have to call that function, and then whatever it returns, you assign it again to name. Only now, whatever this function call returns is stored in name. It returns a string where a white space is removed, so you get a name like this. So this is one useful thing for removing, for dealing with text, is removing white space that you don't need. Another useful one is this module, is this method lower. If you want to test if 2 words are the same, it helps to have them all in lowercase letters. So you don't have to, because you may personally not care about upper and lowercase. And in order to not test all the possibilities of upper and lowercase, you simply make both strings that you're interested in to lowercase, and then you do your comparisons, right? So in this one, name.lower is going to return a string where all the letters are lowercase. So there are these are a few things that you're going to be helpful for your assignment and throughout your studies in this class. So at this point, I'm done with the lecture. I'm going to, those who want to leave, you're free to do so. Those who would like to ask questions, please go ahead. I allowed you. So I'm going to go in the order that I see here.